David, we're going to be playing back and forth on moderators for these sessions. I'm the bad guy, and David's the good guy, and he gets to do the 1960s session. So, David, it's all yours.
Great, I will resist the temptation. So, of course, when I saw, technology in the 1960s, I thought, oh, well, we better look at the 1950s then to set up the 1960s. So I'll try and play against type and not do that. Just one note is if you'd like to make a contribution on a particular subject, just catch my eye if you can, and I'll just keep a running list and then can manage it that way. So you'll know that you're in the queue. But I thought we could begin maybe by talking about early efforts to use computing in sort of automation of printing or other public presentations of text. If there are some early noteworthy efforts that really set the stage for what happened in the 1960s. If anyone has any thoughts on that, John?
I think there is also a graphics component because a lot of the work in Utah was sort of the first visual use of computers, and it was inspired a lot by Ivan Sutherland. And the whole research that was done under ARPA was about man-machine communication. And I think that's intimately related, and graphics are intimately related with the evolution into publishing. That's...
Yes. And there's also, I think, a fascinating element in this of if we just call that loosely the graphical turn in computing, where text becomes a graphical creature, if you will.
Here's get my ignorance. So, someone start and tell me, was there any use of computers or other kinds of these technologies by the beginnings of the 60s in terms of producing typographic stuff, printing, any of those things? Were they using any computer-driven stuff in the 1960s?
The first things, there was software written at MIT to do hyphenation, to break text into lines. The first commercial stuff was Los Angeles Times and the West Palm Beach newspaper in Florida. IBM Computer in Los Angeles and RCA Computer in Florida. What they were doing was basically making line-ending decisions for newspaper text, for columns of newspaper text. You would get in paper tape from the wire service. They print it out and they punch it out on paper tape. And it would be set typically on a Linecaster, on a linotype machine. And the operator would have to make decisions on how you end the line, because it was just endless stream of text. So the computer programs were written to make that decision so you could feed the tape directly into the machine and it would set line by line by line. Okay. That was where things stood. And in fact, that was the genesis of what happened, or where the germ started for Rocappi. Because my father had gone down to the West Palm Beach paper when it first started up and seen what happened there, and then had the idea that this was a sort of a germ of what you could do to do not just newspaper text, but do a whole range of much more complex kinds of things. And we actually hired the programmer from that to be our first programmer.
I just wanted to say, if my memory is correct, in addition to what was happening at MIT very early, there was work going on at the University of Newcastle, I believe.
Newcastle on time?
Yeah.
Yes.
Yeah. Others have things but the early 1960s.
I remember reading in the Penrose Annual about a big conference that was held, I think like 66 or 67, what they were calling a sort of a revolution in the way of typesetting happening, and one of the contributions was by this guy at Newcastle. His name escapes me right now, but it'll come to me. Yeah.
Well, the Newcastle connection, by the way, there was a Rocappi Limited that was started shortly after Rocappi was started in the U.S. There was a cross, and they put money into Rocappi, and they got the right to have Rocappi Limited. And the Newcastle stuff was a tie to Rocappi Limited, because they'd been playing around with stuff beforehand. And I recall the Newcastle people coming to visit us in '65. I'd like to throw something in here that I think is important, because we're going to get tangled up in stuff if we don't do it. I'd done a thing that you've got in a handout here, content-driven versus appearance-driven documents, because we're going to have different strains of this stuff. The strain that was the typesetting strain in the 1960s was text-based, and it was all based for content-driven documents. And the crucial sort of seminal thing that happened with Rocappi at the beginning was the realization that if you put something into a computer, you could separate the content from the presentation. For structured documents, anything that had structure for which the computer can automatically format, you could separate the form and the content. You could then manipulate it, you could sort it, you could change it, and so forth, and you could present it in different forms for different purposes at different times. And that was the focus from '63, '64 on at Rocappi, and that was sort of the driving thing that happened through that strain of stuff that happened, and that takes you right through tech. It takes you right through the tech doc stuff that happened. It takes you to SGML. It takes you to HTML. What didn't happen at that time was work on things that were appearance-driven, where the appearance and arrangement stuff on the page was important. Usually these are things that have to grab your attention, you have to be seduced into looking at, or things that involve heavy use of text and graphics, and you need to arrange stuff. And that's where the graphic stuff that John's talking about became important. We didn't have the computer tools to deal with that in the 60s. We started to get them in the 70s, and that's where we started to see that up in the 70s. But that's why it lagged, not because it was less important, but because the technology simply wasn't ready for it yet.
I don't know how many other people had the experience that I did, but I was totally unable to do any kind of thing with graphics until maybe 1970. So I had already written the first 2 volumes of Art of Computer Programming before I had any way to make a picture except with a Calcom plotter.
Jonathan reminds me of that his father, John W. Siebold, wrote an article in a journal called Journal of Typographic Research in 1968 called Aesthetic Values in Computerized Photo Composition, and it's very much about hyphenation and justification and all of these things. So he was already, and that was just the second year this journal existed, Typographic Research. So, but he mentions in the article that he saw how the hand compositors and the linotype machine compositors made these aesthetic decisions in how to hyphenate, how much space to put in things. But he was confident that soon that the computerization would be able to reach that level with work.
We were doing commercial quality work by '64. The first job was '64. We were doing commercial stuff for New York publishers in '65. And yes, what you do when you start out is you start out by saying, how was this done by hand? What are the decisions that people make? And you look not only at the linotype stuff, but also monotype, where the higher quality stuff was being done. You look at what makes really good composition, and Donald did the same sort of thing. And we were constrained by the fact that we had a 20K word, 6-bit word computer. Okay, no random access storage. Okay, magtape in and out. So if you look at what we did, the whole series of programs, because we were so limited by the size of the computer. But we were getting quality that exceeded the quality that the commercial typesetting people were doing by about '66 in terms of hyphenation, justification, better spacing, better hyphenation, and so forth. So that hurdle wasn't, that hurdle we had passed by that time. Page makeup stuff, the big breakthrough for all this stuff for us came in '68 when we got the first cathode ray tube typesetter that could measured everything in 1/10 point increments, which means that if you're trying to do page makeup of a complex page and you've got headings and so forth on it, you've got to space things out. You could, if you chose to, and we did do this, space out between lines in like 1/10 point increments. And so you have a chance to sort of justify the page vertically and make things fit. That was a much more flexibility. We also, and this is going to horrify you, we also had the ability in extremis to actually modify the typography to help with hyphenation justification. And where this came from was, where we started using this was, we, among other things, we did Science and Health, which was the book for the Christian Scientists that was written by Mary Baker Eddy. She had written it and edited the galleys originally very heavily in hot metal. So the spacing was terrible, but it had to be preserved line for line for line for line because everything was indexed to page and line number. So we're setting this in a different typeface and on a different technology, and we've got to maintain those line breaks. So what we did was we allowed, besides justification, we allowed the ability to change the set width of the type of the line in 1/10 point increments, so because it was pulled out or stretched it in a little bit. And I had a copy of that book for years. You cannot find, if you read the thing, you might be able to find it, but I've given it to dozens of people, and they cannot pick out the lines where this was done because you do it very, very finely. Now, I'm sure that whoever designed the typeface would be rolling over in their grave, but it worked. And that's, I think, the progress that we're all going to talk about here is you start out by doing what was done with the old technology, and you master that. And then you push further and do the things you wished you could do, but the old technology didn't let you do it. And I think that's going to be a theme we're going to see throughout this.
Have Paul and then Bob.
Know what this is?
Solid logic technology.
Any idea? It's a logic board from a CompuGraphic typesetting machine in 1966. I went to the factory and learned how to fix them. It took 2 weeks to fix, and this was so this is H&J. It was made up about 30 or 40 of these cards that hyphenated and justified. So it's exactly picking up where Jonathan just left off. In 1966, 67, CompuGraphic came along and commercialized a broad market for typesetters by doing it good enough at 1/10 or 1/2 of the price of what Mergenthaler or Linotype was selling at that time. So they commercialized the typesetting machine on photo composition to a broader market by bringing the price point down and by using this discrete logic, because we didn't have program logic at that point. So I had to go back to CompuGraphic and learn how each of these boards worked. And this survived only because it was in a wooden box. You got your spare parts in a wooden box that was as big as a suitcase, and that sat in Minneapolis for many years. And when they finally got around to throwing it away, someone thought of me, because I started up the cold type composition for my college newspaper, and they sent me this board. So this is one gated logic, 8 bits, that made a part of the hyphenation justification decision on CompuGraphic, which was awful. We got these great big long spacing in the lines, and we had to put discretionary hyphens in order to be able to get it to break more gracefully. It was awful composition at that time, but this is what did it.
The only way you're going to get...
Nothing?
Yeah. Okay. So, go ahead. I just want to say, the only way you're going to get acceptable hyphenation in the English language is use a dictionary. Okay, I mean, you can do logic, but you've got to use a dictionary. And it has to be broken by, it can't just be syllabification, it's got to be broken on what the proper hyphenation points are in the word, which is not just breaking on syllables. Yeah.
The debate I don't want to join right at this moment. So there is another theme here, which is, especially in the 60s, having to do with whether there were general purpose imaging devices being available. Some of the early photo composers were not, in fact, general purpose. They would be happily set type shapes from various mechanisms, but they weren't prepared to combine text and graphics. But there were others that largely for other applications. I'm reminded of III, Information International, Inc., founded by Ed Fredkin in 1962. They were building 16,000 by 16,000 CRTs for high-resolution exposure for film. A lot of them were military applications, but computer output microfilm, for example, was one of them. They were also imaging at that resolution for things like OCR. Now, III itself was not particularly in the publishing business, but there were people using their equipment and playing with it in a variety of ways. And ultimately, I think in '68, they came out with a thing that they really did target for photo composition, but as an imaging device, was a thing called the FR80. And this was, you know, especially in the computing world, where every computer engineers, as I think somebody alluded to, had the hubris to think they could generate the images just fine, thank you. And FR80 was a godsend because suddenly you could get really good resolution from whatever it is, the bits you could produce.
Interesting that you mentioned military uses of that technology, because one question I had in thinking of computers and automation and dealing with large volumes of text was the government, and I wondered if there's any path into, if that's a path in the story, if anyone has any thoughts about that.
Well, the government printing office was the first institution in the United States to install a high-speed cathode ray tube typesetting machine built for them, sort of special purpose by Linotype. Is that an RCA?
A government
I
printing
think.
office,
When was
a Linotype, a Linotron 1010, and there was also one at Wright-Patterson Air Force Base.
When was this?
This was early 60s, okay? Now, these were typesetting machines, okay? And to understand that, they were actually a hybrid machine. What they had was a Linotype used stationary grids with photographic images on them for their phototypesetting machines. They had a grid, okay, with the images on it. And they basically scanned out the character on the grid and rewrote it on a cathode ray tube, okay? So it was basically replacing the optics of a photographic typesetting machine with electronics instead. It was not digital type, okay? And it didn't do graphics. But it was higher speed than you could get by doing mechanical stuff. And that was the point. It was done for high speed, for high volume stuff.
Dave?
It perhaps is not quite relevant to your question, but I'm sure that a lot of the early systems like runoff and things on the TX0 and Whirlwind, even if they weren't the point of the project, were funded under government contracts.
Does that directly feed into the sort of developments that we were just talking about?
It's your question about the military supporting things.
I mean, there was... Go ahead.
It does, in the sense that the computer equipment in those days was extremely expensive, and people couldn't afford it, usually if they didn't have government contracts. And then you would sort of nibble around the edges of the government contract and play with the equipment in ways that you wouldn't see written into the contract.
But most of the development work, though, was done by commercial firms, and there was a wall. I mean, we applied twice for NSF grants to do multi-level math, and were turned down both times because we were, quote, profit-making. Now, we were running a loss, okay, but we were still a profit-making enterprise, and therefore didn't qualify for the grants. They were given to some nonprofit organizations who produced nothing. You know, there wasn't, except for that sort of stuff, there wasn't any government money. A Linotype 1010 was government money, but aside from that, this was all commercial stuff.
Early images at Utah were done on an 1108, which communicated to a PDP-8, which drove a CRT, which you put a Polaroid camera in front of, and colored filters to make colored images. And you would scan one line at a time, and it would take a minute or two to make a color image. But we weren't interested in the speed. We were interested in the technology to make the image and how the image was created. So that didn't, the only displays we had in the 60s at Utah were line drawings displays, and I can't remember, I think it was a III or something. And you could make line drawings, but they were not interesting from our point of view in that we wanted to make raster images. but I think all your characterizations so far are correct that I know of.
It's an interesting parallel between the software and the hardware, and that's why I wanted to bring this along, but I didn't make my point. So the two were paralleling each other, going like this, and software people were trying to take advantage once the programmable pieces of it. Until we got rid of the discrete logic, we really couldn't advance to the next level in terms of the speed of operation and storage and all the things we needed to produce things like PostScripts and graphics. I was following Alan Sutherland at Utah way back then because I was interested in what he was doing, but it was so expensive that none of us could afford it. And it wasn't until the 6800 came along we had the address space to do graphics in terms of the personal computer revolution, because the Intel 880 really didn't give us that addressing space that we needed in order to be able to start the revolution that became desktop publishing later on. So there was this hardware advance with the software programmers taking advantage of this. And I agree with Jonathan. I think the government research was largely in the research labs, in the ARPA network, the fundamental basic research. It wasn't in the commercialization side of it. That was done by private firms.
Just so we don't forget how that circuit board reminded me, the RCA 301 computer we had at Rocappi, we had this terrible problem that every once in a while it would do something strange, and we couldn't figure out why it was, and we had the repairman by over and over again, and we couldn't find out why. Suddenly it would just go crazy. But we learned that if we walked around to this is 19-inch racks, and we walked around to the third rack and kicked it in the back, we'd fix the problem. Okay, so for about a year, we ran that way. And finally, the guy was back there one time, and he said, aha, and we came around, and it turned out that he'd left a screw there, okay, and the screw would flip over and short circuit between two circuit boards. And when we banged the back, it would pop back up again.
Just to carry on, and one more story. In the first West Coast Computer Fair held in San Francisco here, Captain Grace Hopper, who was featured out there as a fellow of the museum, I had the privilege of going and listening to her way up in the top of the Civic Center. Little tiny room of 20 or 30 of us, every last inch of space. I was sitting at the door, I remember, and she was talking about the origin of debugging. That's why I mentioned that earlier, because the early vacuum tube computers had that same problem with reliability, and they'd literally have to get in and dust the debug, because they were putting all this outside air in, and the bugs were getting in and then shorting out the circuits. So Captain Grace Hopper was one of our heroes from that era.
Oh, I'm sorry. In preparing for today, I was very fascinated by this point that Jonathan brought up about the separation of the content from final appearance, if you will, for texts. I also thought that maybe it was recency effect, but because Bob and I were doing an oral history with Ivan Sutherland, that reminded me a bit of things in Sketchpad for graphics. And I wondered if this conceptual move of separating sort of the content, if you will, or the definition of a thing from its final appearance is something that is common to both kind of the text path and the graphical path that come together in desktop publishing, and if that's something that someone in computers would naturally occur to them. Is that sort of akin to things that happen in a database? There's, you can have all sorts of reports, but your data remains unchanged. So I would be interested to hear people's thoughts on
On the
that.
text side, it was, it seemed to me to be blindingly obvious. And it also has always seemed to be obvious when you talk about line graphics, which you can describe mathematically. Where that breaks down is images, because images typically are captured at a resolution and at a pixel depth. So you're starting with something finite. Now you may desample that, you may change it, and you may manipulate that, but you're still starting with something that does have sort of finite dimensionality to it. Yep. Got it.
Also, it doesn't work for layout.
Yep.
It's been a dream so far, I think, still unfulfilled, that I could take a tag document and do high quality layout of it on devices of with different form factors and different screen sizes and so forth. Certainly that was in the 60s and 70s. Nobody had a clue how to do that. At the very end of the 70s, we started to work on that problem. And I think people have been working on it ever since, with only indifferent success.
Within limits, I mean, for example, one of the things that we did was the King James Bible. We had keyed every possible variation of the Bible, and it had a Bible database. So you could have red letters, not have red letters. You could have diacriticals and not have them. You could have footnotes, annotations, all these things. Okay? Now, Bibles were published on very thin paper, and they were published very size, and they were done mostly at that time by monotype in Holland. Holland and Ireland. I don't know why. And I found that what the pricing was. I found that there was a nicely elastic curve there. If we could set a price that was like half of what it was to a monotype, we could sell. People would do many versions of the Bible. So we did this, and at one point, some significant portion of the Bibles produced in the U.S. came from that one database. And they were all different page sizes, they were different typefaces and everything else. Now that's a fairly simple document because it's all text. But it's a difficult one to do because you have very short verses. And so breaking the columns so that you don't leave widows and orphans and so forth was tough. But the programs handled that just fine. They were absolutely so, it was very, in fact, it was so reliable that I'd taken a chunk of the Bible that we could process with different parameters, and it would tell me how many pages you would have within half a page over the entire Bible. And the reason that's important is that people wanted this to come out to an even printing form. Okay, so you wanted to know exactly how many pages it was going to make. So within limits, you could do that. The problem you're talking about
is wasn't too complex.
The more complex it gets, the more difficult that becomes. And we are still facing that problem.
Oh, here, markup languages. When is the first ones that you're aware of? Larry,
Runoff, MIT.
come forward.
One I'm aware of that was the model for pub to begin with, and for other markup languages that came out around the same time, was based on an MIT work called Runoff.
When was that?
63. It was written by Jerry Saltzer. It was written by Jerry Saltzer.
In 64, we were using $sign plus a letter as tags. And it wasn't a markup language. What it basically was a tag that said, this is a unique element. Okay, now it could be, which means it can be typographically unique, and you can define that separately. It also means that you could access that for data processing purposes. And you could even have elements that would typographically look the same but would behave differently. We did a map index for National Geographic where you had to sort things with the same name. They had a whole elaborate sequence of places, rivers, cities, towns, and so forth, and a sorting sequence. And by knowing that this was a river rather than a town, you'd know how to sort the thing. So, but that was, but the previous one we did in 63 was simply typographic. We used a letter beta plus a letter, a beta plus a letter for typographic stuff. But we discovered within 6 months that wasn't sufficient. Had to move to something that was more general than just typographic stuff. That was very specific to what we were doing. We had to go later in 65 or so to $sign plus 2 letters because 26 wasn't enough. But what happened from that was that a guy named Bill Tunnicliffe looked at that and said, he understood the separation of form and content, he understood what was happening, and he said, we need to make a language for document exchange. And he developed with a committee of people formed by a PIA Industries of America subgroup, what he called GenCode, which was then extended into what became GML, Generalized Markup Language, by 3 people at IBM, and that became SGML as a direct sort of step from that. But the difference was that what they were doing was giving the tags names so that it would say what it was, whereas ours was totally generic. But if you're going to exchange documents, you sort of like to know what it, what it is. The downside of that is that the language now becomes much more complex and has to have a syntax and has to opening, closing parameters and so forth, whereas the simple tags thing didn't require that.
I have Dave, and then I have Don.
Jerry Saltzer's memo on runoff mentioned several prior systems which I know had markup in them. I'm trying to remember who the author was. Peter Sampson maybe did one of them. I'm not sure. If there's a provision in this conference to submit later information, I have the whole sequence written down somewhere, easily available, of the ones up to runoff and then on to the IBM systems that Jonathan mentions.
Let me make a comment about that. We transcribe the sessions as they are, but we can put in a variety of ways additional material, either through personal accounts or other contributions. So whatever you have that will help enrich what we can provide to the historians, please do so. We'll take care of that, okay? I'm sorry.
I just, a similar remark from Dave. I think one of the important predecessors of runoff was Michael Barnett's work at MIT. And he published a book in 1965 called Computer Typesetting, Experiments and Prospects. So, but he, I think Michael claimed with some justification that he was, in a way, the grandfather of computer typesetting.
I think it's fascinating here is that once you say I'm going to put something in the computer and I want to be able to manipulate it in some fashion, then you immediately hit the question of markup, of how can identify things. And so everybody hit this, and everybody came up with solutions for it, because it's the first problem you encounter.
Butler.
I think something that has only been partially clear in the discussion so far is the distinction between markup that gives more or less explicit instructions about what you're supposed to do, indent this paragraph by a quarter of an inch, and markup that tells you what kind of thing it is, where the decision about the mapping from what kind of thing it is to what the typographic effect should be is separated out. And I think it would be interesting to hear more about how that distinction evolved. I mean, obviously, when you're tagging something as a river, you're way over on the what it is side. But I don't know about the other things.
But we encountered that right at the beginning. The first job Rocappi produced was a directory of lawyers, legal thing. I think it was a product directory and then a lawyer one. And so immediately you see, oh, I've got data elements here. So you have to move, almost immediately you move from saying I'm doing typographic markup to saying that I'm doing data element tagging. And that happened, that happened within months.
By contrast, for example, there was no such notion in runoff.
Yeah, right.
The only kind of tagging had to do with the explicitly with the layout.
So I agree, and so just speaking from my own personal experience, so even when Pub started, it was by and large the explicit command style, and people wrote macro packages that implemented the style, much the way LaTeX became the style package for tech. And I think, and then people like Brian Reed went and made a whole document production system in which styles were essentially the main markup, the only markup you were expected to use as a customer, as a user. And the translation from that to actual typesetter stuff was written, if you will, in a separate vernacular. It was the same language, but it was not expected. It was just like LaTeX. You were not expected to delve into LaTeX every time you wanted to write a new little report. And at least in the computer world, which is separate, I think, perhaps from Jonathan's themes, it was those, I think Scribe was the first time that speaking for myself only, the first time I saw that cleanly designed, cleanly separated, an entire system built around that philosophy.
And by the way, we see this today in HTML, where there's a huge conflict. Many HTML pages are just, as Bob says, a huge mishmash, because some of the work is being done by saying this is a quotation paragraph and there's a separate style definition that says what you should do with it, and some of it is being done by saying put this at this pixel.
That's because we are using a language that came out of content-driven documents and trying to produce appearance-driven documents with that language.
I hate HTML.
Yes.
For the
Part of
record. I think HTML is a piece of crap.
HTML is one of the great engineering triumphs of the 20th century. But that's not even consistent with what you say.
If you understand the heritage, from Gen code to GML to SGML to HTML, then you understand exactly where that came from. And it was never, and Tim Berners-Lee did not intend it to be used the way it's being used now. Okay? At CERN, they were using SGML, and the documents that he was producing were SGML documents. HTML was originally a subset of SGML, didn't get full SGML capabilities till much later on, but that was what he was doing. He wasn't doing the sort of documents you're talking about.
This is not 1960s.
No, this is not.
Well, it's a holdover.
Oh, yeah, so I have a question. Computer output microfilm. I don't know if that was the late 60s or more into the 70s. My question would be, does that in any way relate with the broader publishing story, or is it a niche application, a niche technology that just would be used by big corporations so that they don't have to deliver reports on forklift trucks every week?
Barry?
As far as pub goes, in 1971, when it was first done, it was just for monospace line printer devices, but there was a device command that you could use if somebody took the open source code of pub and wrote something to define that device. And that was done immediately, I think 1972, with the FR80.
And the XGP right away, too.
And the FGP right after that, yeah.
I have a question.
But the FR80 was microfilm, we're addressing the question.
We have two, I'm seeing two strands of development here. One was the stuff that came from that heritage, which was the stuff that the computer people were using to publish from computers. And the other one was the stuff that was happening commercially. And it has always been my assumption, and I'd be curious to hear from the people here, that it was the commercial stuff that was the heritage that ended up with desktop publishing. And that the stuff that was happening on the computer documentation side was sort of a separate track, but the people who developed the evolution of desktop publishing came from the commercial side, not from that. Paul, is that no?
Yes, that's true. Mm-hmm. I was aware of it, but I never looked at it because we weren't doing structured documents. We were doing, our focus was page layout and integrating the graphics component plus the text and the markup languages and that whole train of text and, that we've been talking about on the computer science side really had little or no relevance. But I was aware of markup languages because when I started, we marked up all our text that went to those very systems, or at least to the people that needed the markup language, but it was the commercial markup, like you talked about.
I wanted to ask about the place of the mini computer in understanding these general trends and developments across the 1960s. If anybody has any comments about the importance of the interrelation of these two things.
The early H&J programs, where you're just doing hyphenation justification now, you're not doing any other manipulation, were run on the smallest computers people could find. IBM 1130 was the dominant one. Okay? IBM out of Cleveland had software that ran. There are other companies, systems integrators, Sacramento brought software for the 1130. When the PDP-8 came out, it was a natural. So people started to write software for the PDP-8 as well. Now this was just hyphenation justification. This was just doing the simple tasks of breaking lines. And those machines were the dominant machines that were used for that by the end of the decade.
And just second that and tell a story about it. So I got involved. My first real computer was the 1130, and then the PDP-8 right after that. So we had core memory boards at that point, so it was either 4K or 8K, and the board was about this size. And I was down in the, pulling these boards, and in those days you did everything. But the other thing was the telex machine, because it had a paper tape reader on it, and it was commonly available, and it could read 8-track paper tape, which is what the publishing industry was using. So combined with a telex machine that could be the reader with the PDP-8, with the hyphenation programs that were available from a number of sources going back to the 1130.
The question, there seems to be different threads. One, sort of the newspaper threads. What do you do to produce that kind of thing? But I was thinking also about newsletters, all these other limited use extended documents. Were they on anybody's screen during this point in the 60s?
Newsletters, that sort of documents prior to PageMaker was done with phototypesetting and X-Acto knives and paste. Okay, that there wasn't any. You might use, as you got in the 70s especially, you could probably use a phototypesetter that could do hyphenation justification for you. Okay, and often they had screens, and you could see stuff on but just monospace screens. But the actual page makeup was done by hand. But
Waxers.
yeah.
Waxers.
I remember wax.
Don't forget rub-on letters. Letters that everybody would go to and have pages and pages of these things to use with their X-Acto knife.
When Letraset visited Adobe and saw PostScript, their life flashed before their eyes.
I want to discuss or hear about the story of fonts in the 1960s from a technological perspective. But before we do that, perhaps, given what we've been talking about with markup languages and HTML, the beginning to consider that the electronic form of a text might be its ultimate form, and ideas of hypertext or collections of electronic documents, hyperlinking. Just comments on that perspective.
One of the most exciting things to me was when we encountered Ted Nelson, who was then at Brown University, and the hypertext concept, because this fit. This was just another dimension to what we were doing. The fact you could add these links, and you could link, because we were in a world of electronic documents at that point that were sort of. They were abstract in that they were device independent, they were content, they were appearance independent. But this revolutionary idea that you could link these things together in an electronic world just seemed to us to be, that's got to be the future. Because that, again, talking about, you start out replicating what was done before, and at some point technology gives you something you could never do before. And this was something you could never do before, and it was to us it was absolute one of those insights that you encounter, and you say, oh my God, why didn't I think about that? It is so obvious and so powerful.
Blair?
It was a very exciting idea to people that saw Ted Nelson's hypertext stuff or Doug Engelbart's online system. I think the most interesting aspect of it from our perspective today is it went nowhere for 25 years. People tried it repeatedly, and it never caught on until the web. And I think I have a clear idea of why it was that the web succeeded when it did, which is the internet had to be big enough to make it pay off to make a home page. But that does not fully explain why the hypertext NLS ideas went nowhere for 25 years. I think it's still a bit of a mystery.
Because they depended upon people being connected and the you had to have a bunch of people connected, and you had to have lots of documents, and there's a critical mass here, okay? And you never got to critical mass until the web.
It's a little surprising. I mean, there were plenty of organizations in the 80s that had hundreds of machines connected together with LANs. You'd think the critical mass would have been big enough, and I don't think we really understand why it wasn't.
I have Don, and then John and Paul.
Okay. Ted Nelson had the wonderful idea, but he didn't have wonderful algorithms, he had no idea. And his presentation included all the links were two-way. So not only would you be able to read somebody else's page, but they had to know about that you were reading their page, and I don't think there is any good way to implement that. But he was not an implementer, and he hired people to implement his system, Xanadu, and they couldn't figure it out, and I believe that's probably a good reason why it didn't thrive.
And I can understand why Xanadu per se didn't thrive. But that doesn't explain why the idea didn't go anywhere.
John?
Two-way.
Or a bad idea.
It did. It didn't get to the scale until the internet, but with the CD-ROM and the emerging multimedia in the 80s, now this is not 70s, you use, Bill Atkinson, HyperCard, and there's a variety of things. I was fortunate to be at Apple, and doing desktop publishing, right? And that was the closest thing to media and stuff. So everybody that was doing anything with hypertext, or they were all coming and wanting to show me stuff. And that's actually what led me to ultimately shift careers and get into the multimedia space. Because, no, it was happening. It was happening all through, by 84 and 5, even before, we were starting to see all sorts of stuff. And you probably could speak to, I know if Alan Kay was here, heaven forbid if Steve was here, he'd probably have some real strong comments on that as well.
Paul, I had you next.
Yes, and I was going to comment on, pick up on what John's saying there. Until we had the hard disk drive, the spinning hard disk drive, because before that, the board I was taking out at PDB-8 was a core memory board with 4K of memory. It didn't give you a lot of opportunities to do online interactive stuff. Until we had that big disk and CDC and others commercialized that, and Seagate got it down into the smaller form factors, and we were able to fit it into the personal computer. That's what enabled it. The hard drive and the CD-ROMs and all of those storage technologies really made a big difference here.
Did you want?
Well, there was just an example. It was pointed out that until the internet was big enough and there were opportunities there, that these hypertext markup languages weren't successful. It reminds me of a story anthropologist report from the Philippines, which had an indigenous writing system. And it was very easy they never educated young people in it. They didn't have to go to school like we did. But it was mainly used for writing love letters and love notes. And so it said it was marvelous how quickly young people learned this when they came of age and they needed to get a date and meet people of similar interests. So I think in the internet, perhaps money is a greater interest in our time, but still the motivation is there that things take off when you really have a desire to do it.
Let me introduce Mark. Introduce yourself, because Mark just joined us late. He was given bad instructions by David as to when he should be here. Mark, talk about your background just a little bit and your interest
Sure.
here.
So I'm Mark Weber. I'm curatorial director of the Internet History Program here. And I've been studying the history of the web since 1995, starting at CERN in Geneva with the web team there. Co-founded the first two organizations in that field. And I also have before I did that, I was a computer consultant, mostly software testing, some UI, and technical marketing and training writing. And I actually wrote a few manuals for Canon page description languages in the late 80s, associated with Luis Trab-Pardo of Imogen, who some of you must know. In any case, with hypertext, I think there are two factors that kept it from scaling. One was that hypertext really comes into its own when you're reading on the screen, when you can follow the link instantly. And until you had a critical mass of people reading on the screen, that just didn't make a lot of sense. The other factor is that the hypertext systems tended to be proprietary, so that people were asked to convert all their existing documents to something, and there were some beautiful ones. But there was a high buy-in factor, and the web took off to a large extent because there was no buy-in factor. It was easy to install. And hypertext proved to be tremendously popular once people didn't have to put much effort into getting it. So those would be the 2 points I wanted to make. And sorry, addressing something earlier, the HTML was originally meant to be device independent, as Jonathan was saying. It was really intended to be used on everything from, a voice browser for people with a hearing impairment to small screens, teletypes, whatever. And it really did it reacted very badly to getting turned into basically a way to lay out type. But it started with a quite different intention, and that was largely because the original web was meant to be, people were meant to be editing as well as reading. So it was meant to be something that, everyone would write their own documents in, and that kind of, once it moved into the professional realm of programmers and graphic designers, that's when they sort of pushed it in a different direction.
I have Dave and then Paul.
There are many things I think that supported the web, but my view is that the web let amateurs do navigation. The point-and-click interface let every grandmother and school child do something they couldn't do before, which maybe leads to where suddenly there's a big market for putting up your home page or your website.
Speaking to Butler's point about finding an organization that would have had an internal customer base or something like this, I think if you go back to the Plato system at the University of Illinois, it was originally for computer-aided instruction, but in fact the students could write their love letters, and there were huge discussion groups, and I think that led, Ray Ozzie was there, and then I think there was Vax Notes and Lotus Notes. It was a little bit of the flavor of it, but in these sort of closed communities.
Question here. You all talk in terms of what was needed to make a desktop publishing required a small machine. So we had the capability on the large computers in the 1960s to do any of these things pretty much that you wanted to do. Why didn't it really move ahead a lot faster?
If you're talking about large computers in the 60s, you were talking about a ton of money. The machine which we had, which was, it was 20K 6-bit words and mag tape, there was no random access storage. That was $3,500 a month rental.
You didn't buy IBM. We could have charged you more.
That's right.
But we had
I didn't buy IBM because this is before the 360, first of all, and secondly, a 360 was beyond our budget.
60 is 66, but the 1130s, the 1401s, all these things were there, and then we had time sharing. You had the ability to buy a little piece of it. I'm just surprised that with the creative abilities of these people and the needs, that some of these things didn't move along. I was working on applications. I didn't do it. It didn't even come to my attention.
The thing that I wanted most was not a more powerful computer. The thing I wanted most was a window into that computer. The visual, even for doing text stuff, the visual window into the computer so you could go in and change something, correct something, rather than doing this batch. That was what we really wanted.
2260? I mean, we were doing online stuff. We were doing real-time stuff. We were starting to build real-time systems, and yet I didn't come across it. I was building applications for everything, and this never came to our attention. I was at IBM then.
I have Paul, and then Matthew, and then Tom.
Well, the reason it didn't, in answer to your question, was I agree with Jonathan. One was cost. We're talking an order of magnitude of cost. In a computer room with a raised floor, I was there with the 1130s and stuff. It was a big deal to maintain that whole infrastructure, and you're paying thousands of dollars a month to IBM or whomever to just run it. Second was control. We needed to get the technology to a point where the individual user, the window into the computer that Jonathan's talking about, giving the controller back to the customer, the person that's the creative. And we have this intermediary because of the cost and the complexity. And then the time, because, you know, the reason that desktop publishing was a revolution is it's one order of magnitude in tech shift all at once. We had the technology, we had the software, and we had the control over the process that took so long, was so tedious before. When you put those three things together and package it, and that's what I did with PageMaker and desktop publishing when I came up with the term, was bridge that gap because I understood the technology and what it was possible, and then I worked with the software engineers and the programmers to bridge the gap between the two. I was the translator that allowed, and that was the focus, was creating that marketing message with John Scull and others.
Matthew.
We've touched on this, but I'd be interested to hear a little bit more about screen technology and how important it was to sort of have that surface where you could see the text but sort of not see it at the same time because it was never going to be the same as what you got on the page. So screen technology, hardware, resolution, how important was that, and when did it start to happen?
Before we turn to that question of screens, if you will, I just want to check with Tom and Larry that we're not diverting from the thread we were on before. Maybe we can loop back to screen in a moment, Matthew.
Yeah, I had, I think, a similar question or observation to Matt, but my impression, because Bert raised this question, right, why didn't people start desktop publishing with mainframes in the 60s? And obviously, yeah, one reason is the enormous expense. It's not economically viable. But my impression is because of the fundamentally different way in which people interacted with mainframes and even with time-sharing systems, you couldn't get that responsiveness, you know, visually of like dragging and dropping, you know, moving things around. The same kind of way that's what made VisiCalc such a compelling application. The, you know, the rapid scrolling, the instant responsiveness that you didn't get with, say, a time-sharing or mainframe-based financial kind of package. So, as there are people here who know very much more about this on the technical level than I do, I think I'd turn that into a question. First, could we imagine a different world in which people did produce highly responsive visual applications on mainframe or time-sharing systems? And second, like basically, do they agree that that's what is an inherent precondition that you couldn't get without having your own processor and a frame buffer?
Before Butler responds, we're kind of intermixing responses to an earlier question with new questions. So we have screens, kind of interactivity. Larry, you wanted to say something?
Yeah, I think a lot of what I heard is likely there are technological limitations, and it's not like the day they go away, all of a sudden there's an infrastructure around or critical mass. So I can, and also there could just be a lot of things going on at the same time. And investors have to make choices. By investors, I mean both these VC-type people outside of large companies and the executives and boards of large companies. And I think there was a period of time, at least one period of time, when the investment community looked at business applications as being the only way to make money, and you're not going to make money on consumer applications because no one's going to pay for anything. And I think there was just of advertising, other factors that make it so that things that would have been described to you or even shown to you in the 60s and 70s, if you asked somebody to put their own hard-earned money behind this, they'd say, people aren't going to do that. And it would be a little bit off the track. Say, well, maybe they would, and maybe we could find a way to, get a lot of eyeballs, and we'll find a way to pay for it.
I have Richard, and then Butler, and then John.
We talked about quite a few different technology areas why the hypertext did not take off for 25 years. And one of them, I think it's important, but has not been mentioned, was storage technology. Back in the 60s, we sort of take things for granted that everything is on a hard drive readily available. But back then, what was available was not really online, but call it near offline. It's mag tape. You have to actually get somebody to mount that foolish tape for you. And you can't do that with hypertext. To send a message to somebody to mount that tape. There was a technology called deck tape that came out early 70s. That is a random access mag tape that actually divided the tape into small chunks, and there's a directory in the front end of the tape. But every time you have to access a file, you have to spin the tape back to the beginning to get the directory, because there's not enough memory to remember the directory structure. So you can't mount a big tape in there because they will take you 20 minutes to get to the directory structure. So they have these itty-bitty little things. I think that HTTP did not take off because we didn't have a cost-effective online, real-time data access until much later.
Make this comment. We were actively building online systems in the late 1960s with these big disk drives. Cost, I think, may be the factor that is key here, as well as size. But technologically, we could handle speeds, we could handle the complexity, and yet, as I say, I was asked to build lots of applications. This never came to my attention.
To be a very high volume application to pay with the technology of 1970.
Newspapers are high volume. Newspapers are big money.
Univac Fastran weighed 5,000 pounds and had about 5 megabytes of storage on it in the 60s. I mean, it was the IBM 1311 disks were huge, horrendously expensive.
Bought a disk in the late 60s that's taller than me, 6 feet high. It's single platter, and it was mounted, had steel bolt holes on the base, mounted on the ground. And we didn't know what the bolt holes were for until we were debugging the system, and every morning we came in, the disk moved. It was processing based on the Earth's rotation, and the bolt holes was to lock down so that it doesn't precess. All right, now, and that was about 20 megabytes.
There was a story that Sale at Stanford had a fixed head disk from Libroscope that had so much inertia that if it got loose, it could roll all the way up to the top of the hills.
That was the story, all right.
You say that wasn't true?
First interactive environment I went into was the park with the Alto.
Yeah, I want to just pick up on this, this business about time sharing and mainframes and all that. One of the reasons the Alto was so successful was that prior to that, getting a display on a mainframe that would give you any semblance of interactivity was either impossible or hideously expensive or extremely special purpose. And we tried repeatedly starting in about 1964 and running up until we thought of the Alto to solve this problem, and we never could succeed. So I think to the extent that that was important for this application, it's a sufficient explanation for why the things that Bert was asking about didn't happen.
Skull?
I was actually just going to say, I think the people that could probably give us the most insight earliest are the guys at Park. because that's where everything was ripped off from. I mean, Steve just, Steve and others just, you needed the graphical interface, you needed fonts and, the ability to cut and paste graphics and fonts and everything. You need all these fundamental things. You needed a laser printer, you need to have a way to describe it so it went from what you saw on the screen to what came out of the printer, i.e. PostScript. You had all these enablers. You needed to have some kind of communication between them. If you didn't have all those building blocks, only after that, then you could have the smarts, which was the software that took advantage of all that to actually have applications, be it page layout or be it more, TechDoc or some other more, or forms, or whether it was, presentation material. Then all of a sudden you had everything. But until the foundation was laid, it's no surprise, and we just happened it was around 85, it's magically all, boom, the Big Bang Theory all came about, and you had a lot of really cool things could happen.
Steve?
Yeah, so I'll give you my perspective. I was a student at MIT in 1974, and shortly thereafter, and I'm not sure what the date was, but I remember seeing the manual with Butler Lamson's name on it, because MIT got these things called altos. And even though we had all this computing, the alto was really transformative, because not only did we have altos, but we also had this thing called a Dover printer. And so the Dover printer could actually print out the stuff that you were creating on the alto, and it's all WYSIWYG. And so to me, I think that was the transformative moment. That's really the where things could really start to take off, because you had access. It wasn't that the machines were expensive; it was the access. You could have these machines, but you'd have to have reserved time on a terminal. The terminal were line by line, or they were text terminals and not WYSIWYG displays and so forth. So to me, I really think it was the thing that was transformative in my view. Was the Alto plus the Dover printer, that you could actually create these documents and share them. And of course we have networking as well at the time. And so those things all coming together is when things really started to take off.
I have Chuck and then Don.
So sorry, let me get a little closer. So in 1982, or 72, excuse me, wow, I was writing my thesis at Carnegie Mellon. And I believe I was the first person to do an electronic thesis generation. I did not use a typewriter. It was some software running on a PDP-8 with a deck tape for memory and hooked up to a Xerox XPG, which XGP. Yeah, I had all the right ones, just the wrong ones. An XGP, a Xerox graphics printer. And because I had some mathematical-like symbols and the font that we had didn't have them, I actually went off to a line graphic display and was able to generate my own characters and add them to the font. And I produced my thesis. So the pieces were just starting to come together. And it was possible to do those kind of things, just like you were doing with the Alto at MIT and we were doing at Park.
So can we access your thesis on the net now?
I made the mistake of never copying it from the deck tape when there were still deck tapes around. So I can do it for you, but I'll have to.
I mean, CMU was probably involved with University of Microfilms, and all theses were scanned, no?
I can just scan it for you.
Oh, okay, well, I mean, I think for the world, not for me.
I'm sure the Computer History Museum can read the deck tape. Do you still have it?
No. But I was going to talk about the XGP also. I mentioned earlier the Penrose Annual. The Xerox graphics printer was actually it came out of a rank Xerox. Another division of Xerox in England had invented this device, and it was originally not to be it was not, it was digital internally, but the original device scanned and then reproduced on xerographically, but it didn't have digital input. The XGP added this extra, I don't know exactly how it happened, but somehow somebody in America added this extra thing that the computer could supply the bit pattern. But because the thing was so funnily designed, it had different resolution. At the edge of the page, the resolution was about 100 dots per inch, and in the middle it was about 250 dots per inch. And
True.
what?
That's not true.
The other way? No,
It had the same resolution across the page.
no, it didn't. If you
Well, you had a broken
could
one
look
then.
at the you could print the letter A over here, and you could print the letter A over here, and it would be different. Our eyes adjust to this. It might
Not
have
by this factor of 2 that you're telling us.
okay, maybe it's a factor.
Maybe it
of-
was 10%.
No, it's more than 10%, I swear. But anyway, the Xerox graphics printer was really a revelation, and Dover was very consistent and much better later on. But that was several years later on. To explain why I know that the XGP was important was because every once in a while, the XGP at Stanford's AI lab would go down. And on those days, the parking lot would be less than half full.
I think, Bert, did you want to?
The XGP was, by the way, was originally built as a high-speed fax machine.
Right.
And the reason that it was available
That's right, fact.
for your applications was that it was a complete commercial failure as a high-speed fax machine. Mainly because the high-speed phone lines were much too expensive.
It's
Okay.
the LDX, long distance Xerox. You can look it up and find pictures of it. 2 refrigerator size units. One was the scanner, one was the printer. Required a leased line in between. It had a scanning CRT. It had roll fed paper, and it was sort of an abomination as a long distance. It was an early fax machine, LDX. But then someone said, well, we'll just take the output side, put a digital input on it, and all of a sudden it's a laser printer, but it was really a CRT printer.
Still a commercial failure.
Yeah.
Gentlemen,
I still insist that it had variable resolution, but that
Gentlemen,
didn't make any difference for the fax machine
To the parking
application.
lot.
Arnold?
No.
I take the privilege of age. Again, look, this is very fascinating because we've taken about an extra half hour on the 1960s, which basically you've all told me really had no significance at all going forward, a total waste of time. However, I'd like, you're all younger than I am, and I'm still saying that the 60s didn't really, it provided something, and that's where I'd like to end up this session with. We'll start the next session here and think about it as we grab lunch. No, you don't have a chance. You can do it later. What were the key elements that came out of the 60s that underlay what happened then, Xerox PARC and elsewhere, during the 1970s? So we're going to start our next session with that kind of thing.